9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
It's maybe not so understandable from the first glance. Which code? Where is it? Where is this code?
What do you mean?
Like to claim the airdrop, the wallet.
Yeah.
Code required. What is this?
Yeah, and the code will be, it's in that metadata that we're gonna post. So that's gonna be kind of the scavenger hunt, like the way that we'll have people go look up, there'll be like a key that,
yeah.
a metadata key that you have to go look for, and then you'll be able to find. I'll show my screen real quick. So this will be the metadata.
Yeah, nice.
Can you say something now?
Can you hear me now?
That's much better.
Cool.
How's the audio sound?
You sound good.
Cool. I'm trying better microphone that I'd be using in the past. So yeah.
Cool.
So, hey. Cool. Okay. So I've been basically, my plan for today is to mint some native tokens, and then try to kind of explain each part of the process, and then if we have to, how long do we want this to be? Like
well, so we can just go any amount of time, and we can always edit these down to, what is consumable or something,
Right. Because I mean,
but I was kind of anticipating, spending at, each time about an hour together, give or take.
Yeah. So my proposal is that basically today we cover the setup of kind of how to get an easy way to get the Cardano CLI working. Go through the process of minting some new tokens, getting those transferred to, out of the CLI account onto someone's wallet, and yeah, going through what all of those commands do and how they kind of work, and then essentially I expect that that'll probably, by the time we've discussed everything, take an hour. And then I don't know if you guys have time, but I would like to basically carry on the NFT side of things, like tomorrow or in the next few days, if that works. I think conceptually everything's together, because then the next thing is to basically, right now I'm doing all of this stuff on the testnet. So like the token minting and stuff like that is all on the testnet. So we go through the basic, like the brunt of it today, and then maybe tomorrow. I'm saying tomorrow, but hypothetically, when we all have a time together next time, we do the slight variant of it, which is how to do it for NFTs. Gotcha. And then once we've kind of done that, then we'll practice that procedure twice, so that we can then do actually mint those live in NFTs on the mainnet that we wanted to do. Okay. So that's my proposal. We can plow ahead also, and do the NFTs today. I'm just conscious of time and I guess the length of the videos. And
yeah, the thing I really want to be able to get clear today is how we can, easily leverage Daedalus to be our node. Really make this.
So that's something I've spent a lot of time figuring out, and to be honest, I went too far. I went down a rabbit hole of trying to make transactions from the same kind of wallet, from the same underlying private key that runs for Daedalus. Like sort of mint coins directly to my Daedalus address, and nobody's doing that, but I really tried, and I got quite close, but in the end it fails, right? So I've stepped back, and we're gonna do whatever everybody else does, which is basically when you're doing this command line stuff, you're kind of doing it with its own set of keys and its own like, yeah, it's essentially its own
makes
wallet.
sense. You're not going to be issuing from an account in the Daedalus dashboard.
Yeah. Now, I think it's theoretically possible, but it's just this derivation of keys. Like, I've kind of worked out all the steps, but in the end, I just get a mystical message saying, "Nah, I don't accept." Like the signature you finally made wasn't accepted, so I did something wrong, and I don't quite know what it is. But anyway, that was a rabbit hole, and I would have liked to be able to demonstrate that because that would have been cool. But no.
In the future, I have a feeling it will become in the future.
Yeah, I think we're very close now.
Yeah. Cool.
The other reason why I want to hold off till like, a day or so for the actual minting of the actual NFTs that we want to mint for this is because you need an up-to-date Cardano node, and a few hours ago I installed Daedalus, like the mainnet version on this laptop, and it's still syncing. So it may not be synced by the time it's time to do it, but tomorrow it'll obviously be there. So
cool.
With all those caveats, let's get started.
Do you have a screen sharing capabilities?
Yeah. I think you may have to give me permission. Oh no, there it is. You have to give me permission.
Just a second.
For the time of the lesson, we stop video. Yes.
Yeah,
we'll just use the screen share.
Yeah, cool.
I mean, I'll do that.
But keep your audio on so we can so we can discuss things, because like the more questions the better, I guess.
Yep.
And one more thing that I wanted to mention is right now I'm demonstrating this on a Mac, and most of what I'd like to do is most of these commands are going to be like the same, but there's a few ways in which I store values and variables and stuff like that are Unixy. So on Windows, they're going to be slightly different. So my proposal regarding that is that I basically, once we've gone through the thing and recorded it, I also do the thing on Windows. Either record it, or alternatively for the Windows version, I just write an article saying, this is how you do it on Windows. Like, these are the commands that were explained in the video. And I'll kind of point out, during the lesson, like, this would be slightly different on Windows. Like, the syntax here is going to be slightly different on Windows, and so on.
Gotcha.
So yeah. So I guess, but if you're using Linux, then you can basically follow the Mac instructions almost verbatim, not much changes. So yeah.
Cool beans.
Okay, so I should be able to share screen now. Tell me if you can see my screen.
Yeah, we can see.
Cool. All right. So okay. That came to the bottom. Sorry, we'll just make some room. Okay, so basically, in order to mint some tokens, the first thing we have to do is become familiar with using the Cardano CLI. From the command line. So that's the first thing. I'm just going to bring my note. Yeah. So I've got a testnet version of Daedalus running right now, and I found out that my Daedalus was installed here. So essentially it's in /applications/Daedalus testnet app. That's the core thing. So if we cd into there, so because I have spaces in this thing, you just have to put it in quotes. It's going to be the same on Windows, I think. Right. And there's stuff in here. So if we go into contents and Mac OS, this is the interesting one here because it actually contains this like Cardano address program and Cardano CLI and Cardano launcher and Cardano node. So that's important for me because I like all of these programs are what we're basically going to use.
And those are all separate programs inside of the Daedalus folder.
Yeah, that's right. So you could install these directly, but in order to, if you're already running Daedalus, then you already have it. And the nice thing about it, if you use it here, is like, for example, that CLI is going to be the right version to contact this node. So the versions are going to match. You're not going to have to worry about that stuff.
Makes version control very easy.
Yeah, I mean, to be honest, CLI and node used to be separate, but now they're kind of packaged together anyway. So it's not the end of the world if you directly install it. But I think like it is the thing that people struggle with the most, and everyone knows how to get Daedalus running. So that's how they are.
Gotcha.
Now, this is kind of a Unix specific command, basically, that I do. Sorry, one question. Let me just switch. So I just, my bad. I will just come. Can you still see my screen?
No, now we got your name.
Okay. I will bring it back. Cool.
Yep.
I'm in the same directory. And just, yeah. So the first thing I do is do this little incantation. And let me quickly, basically this is to make this path, this directory available. So right now I can run, for example, Cardano CLI like that from this directory. But if I move to a different directory, then I won't be able to find it. So what this path variable does is two things. First of all, PWD is print working directory. So if I show you what it looks like, it's just that. So what I'm saying is put this update path, put this PWD on the front of it, and then the rest of what the path was at the end of it. So path on both Windows and Unix type systems is just a series of entries, and when you type a program name, it finds it on the path, right? So this is simply kind of making it available so we don't have to be in this Daedalus directory. We can still access the commands. That's the goal. So yeah, so now I'm in a different directory and I can still access, for example, Cardano CLI.
Okay,
that's the
gotcha.
I wanted to do. Now, the next one, which is really important, is the Cardano CLI, and basically the Cardano node, when it operates, it has a file which corresponds to a socket. So everything communicates to it through that socket, which means we need to find the existing running socket file in order for our CLI to connect to it. And the way I did it is I basically just I kind of run this command that shows me all of my running processes, and then I find Cardano node. And just before I do that, I'm just going to quit my mainnet one, so there's only one result, so we don't confuse things. Yeah, like that. So we have a few results here. There's this Cardano node, which is our actual node that's running, and that's got a socket path, but it sort of unhelpfully doesn't tell us, like, the name of the file is Cardano node.socket, but we still don't know where it is. But there's this other thing that Daedalus runs, which is this Cardano wallet. So the way Daedalus works is it's got a UI. The UI talks to this Cardano wallet program, and then the wallet talks to the node. That's kind of the separation of layers that they do. So for me, what I was really looking for was that there's this path here, which is essentially the full socket path. So we want to copy that. And let me just refer to my notes. Yeah, so there's a environment variable called Cardano node socket path. And we set it equal to that. Cool. So that should be all we need. So what we've done is we've updated our path, so we have access to the Cardano CLI executable. And we've updated this environment variable Cardano node socket path, and that's what the Cardano CLI executable will look for to know which one to talk to. So for example, if we wanted to switch on the testnet and run them both simultaneously, the thing that would change, switch on the mainnet, the thing that would change is the socket path. Like right now it's in the testnet one, the mainnet one would be separate.
Gotcha. So you would get, it would just be a difference of choosing a different folder path inside your.
Yeah, so you basically have to export this environment variable to be a different folder path, and then that would point to the other one.
Very cool.
Now, so let's do our first Cardano CLI command. So yeah, the command is called Cardano CLI, like that. And then you query the tip. So that's going to kind of tell us basically what our recent, I think what the current block we're on, what current slot we're on, and just essentially where the blockchain is up to right now.
Does tip have a meaning, or is tip, what does the tip stand for?
Like if you think of the blockchain, you know, a blockchain in general is like you've got a bunch of blocks, and when a new block comes in, it points to the previous block, and then it's the kind of front, like it is the current state. So the blockchain is all of the blocks in the past up to the tip, and the tip is the current one that we're on now.
Makes sense. Okay, that's clearer now. Thank you.
Like the tip of the I mean, chains.
The tip of the chain.
Yeah, it's the tip of the chain. It's not the best terminology, I guess, but that's what it means. Yeah, and other blockchains, they might call it a head or something like that. Same thing. So that's what a tip is.
But is it like the same, like a block number, or no?
Yeah, so you see right now we've got a block number in it and a slot number. So if we wait a few seconds and we do it again, we gotta wait a few more seconds. I think it's 20 seconds per slot. Is that right?
That sounds right.
Let's just kill a little bit of time, and maybe now. I promise you it does move because I've seen it move.
Yeah, maybe on the
there
test
we go.
net,
There we go. It's moved.
Yeah.
Right. So
maybe on the test net blocks like not so fast, moving not so fast.
I have a feeling they're the same. I think we were just impatient. It's moved now.
Yeah, impatience is.
Yeah. So that's the query tip. And I mean, I don't right now care about what that tip is. What I do care about is that my CLI is working. Now, this testnet magic, what does it mean? So essentially, there are two parameters that you can use here. You can say minus mainnet or minus testnet magic. And the magic is like the magic number that identifies the testnet. And like, so if there were multiple testnets running, you could get to different ones with different numbers. But like the official testnet that Daedalus runs, it's this number here. You'll find that in the Cardano documentation, they use 42. And that's just like an example placeholder. But if you actually wanted to work with the same testnet that Daedalus is associated with, then you got to use this number. So 109.79.110.63.
What would happen right now if you were to submit that one right there again, so we see what block number it's at?
Yeah.
And then now paste it again and put 42. Is it going to return that same block number and slot number?
Yeah, it's going to give us an error, but it's a good question. Yeah. Yeah, the only one it'll work with is that one.
And where did you say in documentation it used? It's weird.
Yeah, so like a lot of the Cardano documentation that talks about this stuff, like you'll see 42, and just remember when you see 42 for testnet, just use that instead.
Okay. Thank you.
Yeah, I think basically it's whatever net your node is connected to, right? So maybe, yeah, somewhere out there, maybe someone's running a Cardano blockchain with, I mean, maybe inside IOHK, maybe they're running a little test one with 42. I'm not quite sure.
Gotcha.
I mean, 42 is kind of a famous arbitrary number, you know, but I don't know if it corresponds to anything in real life or not. But in terms of talking to the actual testnet, the one that Daedalus is configured to talk to, that's this one.
Okay.
So yeah, you'll find, and yeah, again, you'll find lots of documentation that says mainnet here. You can replace it with testnet magic equals that. And similarly, if you find any documentation that talks about testnet magic, if you want to run it on the mainnet, you'll say mainnet. Of course, you'll have to be connecting to the mainnet node for this to work. So right now we're connecting to the testnet node because that's what's running. So it's a little bit, you know, a few moving parts. But anyway, that's like an important step one, which is we are able to talk to the Cardano node. And this step one is what's going to change the most. What's going to change the most between Linux and Windows, because all of these previous, like these export paths, they're going to be slightly different. This trick is definitely going to be different. So I will record this part of the video definitely for Windows specifically, so you can kind of get to this point where you can, you know, you'll still be typing in the same command. Sorry, I guess I shouldn't.
Yeah, but connecting to the Cardano socket in Daedalus will be a little bit different.
Yeah, just this syntax of like it's pretty similar. But you know, Windows doesn't have this pwd command, so you might have to paste the actual path there or figure out, and then like the command is called set, not export. You know, it's slightly different. Conceptually it's going to be the same, but
gotcha.
The actual syntax is going to be different. So yeah, we'll record that. Like I can record it tomorrow or something, and we'll, yeah, that way you can do this on Windows too. Okay,
Cool.
So we've got the tip. We know where the blockchain's up to. The next thing we're going to need is just 1 second. Just pulling up some things in the notes. Okay. So let me just find where he does the keys. Oh yeah. Okay. So what we'll have to do is generate some keys. So like I mentioned before, this is the easy thing to do, essentially. There are 2 commands you have to run. There was a harder version where I wanted to actually connect to the key of the Daedalus address, but I've given up on that. So this is the command, essentially. So it generates we need stake keys and payment keys. So that's creating like a stake address. Basically, so we got Cardano CLI again, and the sub command is stake address. And yeah, we generate a key, and that's going to save 2 files. This stake V key, V stands for verification, so a stake verification key, and also a stake S key, which is signing key. So like this is the process of basically building up a new wallet for ourselves so we can do this stuff in the wallet.
Now, after this has been generated,
Yeah.
and this is all done, you could go back to Daedalus though and add this account to your list.
Yes, except you will have to figure out how to convert this thing into like a passphrase that Daedalus will accept. And there's a way, there are tools, they just, yeah, I'll have to do some thinking about that one. I think it's theoretically possible, but it may be a bit awkward. But yeah, like I said, the goal here is really to mint the tokens, send them to our Daedalus wallet, and then, you know, we can use this account for more minting later, or like, you know, transfer all the ADA out and you can shut it down. It's kind of
Gotcha.
like that. That's kind of
Gotcha.
how I'm treating it. But
So
yeah,
I'm just
I think at least,
sure.
yeah, just
I
at least
understand these clearly. They're not really designed for when you create these accounts. They're not really designed to be like your, you know, like a savings wallet you have on Daedalus.
No,
They're really meant for production only.
Yeah. Although
Okay.
you'll find, yeah, people who run stake pools go through these similar processes. So I think there's a way probably to get it into Daedalus. I just haven't explored it. I've explored it from the other direction, and I've had a few hiccups, like going from Daedalus to these keys without having to generate them. But
Yeah.
for now, we're just going to generate them.
Sounds
So
good.
these are our stake addresses. Then we'll generate our actual payment keys. So again, it's like one is a stake address, one's an address. So we have 2 keys. And then the other thing we'll do is we'll build a payment address. And not 42. So let's look at this command because it's a little bit different. Like, so this is building a payment address. It's setting its payment verification key file as this payment V key that we previously created right up here. And it's setting a stake verification key file as the stake one. So we create two keys, 2 key pairs actually, which both contain verification keys and signing keys. And just approximately, like if you've heard public and private keys, your signing key is your private key, your verification key is your public key. That's the kind of correspondence there. And then there's this out file parameter, which is, we just make a payment.adder that'll contain our payment address. And we got to give it this testnet magic again. Like basically every command's going to have that. So, and now we should be able to look at the payment address, and that's what it looks like. So it's a testnet payment address.
Gotcha.
So the next thing we're going to do is look at the actual balance of this thing. So yeah, I'll explain this dollar thing, but let me just add the testnet magic. And also it needs a Mary error command. Yeah, so this is an important command to remember. So it's essentially query again, just like we queried the tip. This is querying the UTXOs. So UTXO stands for unspent transaction outputs, which is kind of a reasonably low level blockchain term, but it's going to become important. But essentially, I think it's best that we just see it. So just quickly showing you this part here. That's like a little Unix shorthand for basically pasting the contents of this file here. So instead of using that, we could also we could just paste that address like that. Same thing. I'll go here just to minimize the amount of Unixism that comes in. So yeah, essentially we got we're querying the unspent transaction outputs for this payment address that we've just output. And we're going to get an empty table because there are no transactions that have ever happened to this address, right? That's completely new and completely, empty. So whenever you make a transaction, you need a transaction to base it on. And the basic reason for that is because every transaction needs some ADA as a fee. So if you haven't got any ADA, you can't make a transaction. So we're kind of stuck here unless we transfer some ADA to this address, which I'm going to do now. So what I'm going to do here now is...
This is test data you got from a faucet somewhere else in a different account?
Yeah. So on the testnet, Cardano, IOHK have a faucet. You can get like, I think 1,000 test data per day on it. Woo! So I've just got to it seems rich. A lot. But yeah. I did it for like 3 days, but then you're supposed to kind of give it back because so I'm not requesting it anymore. And if you guys would like some for some testing, I can send you some. But anyway, for now, we're going to send some to this address. So I'm just going to update my screen sharing and add my Daedalus to it while keeping the terminal. So can you see both my screens now?
Yes, I can.
Yeah, cool.
Yes, we can see.
Okay. Basically, yeah. So I'm sending to this address. That was that address there, right? That's the one that was created. So I'm sending to that, and we don't need too much. So I'm gonna send like 2 ADA. Yeah. Just because previously when I did this, I sent more, and then it's just left over. And let's just do so there's a little bit left over, because that's kind of an important part of the whole transaction building process, which we're going to. So 5. So we'll just wait for that to transfer. It reckons it's done.
That was quick.
So if we run that same command, let me clear the screen because now we have a result. So yeah, we have our transaction hash and a transaction index and an amount of 5 million Lovelace. So all of the, on the command line, all of the amounts are in Lovelace, and there's 1 million Lovelace in 1 ADA. So they're like super small cents.
Gotcha.
Okay. So now we have some, like, what this means is now we have a transaction associated with our account that has not yet been spent, meaning we have 5 ADA in our account. Now, this is a little bit strange, and it's not like a wallet at all. That's kind of what that's what your wallet is. Your wallet is a collection of unspent transactions, which is a kind of weird way of thinking about it. But it becomes important to understand that when you're constructing these transactions manually, as we're about to start doing. So if somebody else sends me another, say 3 ADA, then I'll have 2 transactions here. Like one will have 5 ADA and the other one will have 3 ADA. And under the covers, say something like Daedalus converts that into like a total sum of 8 ADA, but that's not actually what goes on. Like what goes on is you have 2 unspent transactions, each of this amount. And basically when you're constructing, remember every transaction needs an input and produces an output. So when you want to spend some money, say like we're about to, this transaction here is going to be the input, and there's going to be 2 outputs. One output is like, say if I'm sending you some of this ADA boon, so I'm sending you 2, right? There's going to be one input, which is this transaction, and there's going to be 2 outputs, right? Like one is the amount, one output is the amount I'm sending you, so that 2 ADA, which is going to end up on your account. And then the other thing is going to be the change from 5 ADA, meaning 3. That's going to come back into my own account. So it's kind of weird like that. Like there's only ever like you, and then this whole transaction is spent. So there's no partially spent transaction. So if this amount ends up being, like if the amount I'm transferring isn't this whole amount, then there's a change transaction kind of thing. And that becomes important because then my wallet ends up containing that change transaction, which is like subtracting the amount I sent, but it's weird, right? It's built in terms of these transactions, inputs and outputs. And there is a reason why I'm drilling this, because really you have to be aware of how this stuff works if you're going to do it from the command line. So that was just a brief one. I hope it becomes clearer as we do some more.
No, it does help to understand how the balances are held in the account.
Yeah, so it's like, the other thing is, so I talked about this being an input with 2 outputs. Now let's say that we wanted to transfer 10 ADA and we had 2 unspent transaction outputs with 5 ADA each. Then those 2 would be inputs into the transaction, and then the output would be, wherever we're sending it. So there's like, wallets kind of automatically do that for you. They just look at how much you want to spend, find the appropriate transactions and spend it. But like, when we're doing it manually, we kind of have to do it manually. Anyway.
We can add that Bitcoin is working also this way.
Yeah.
Basics.
I think every blockchain, it's the same concept. Yeah.
Some blockchains have account-based model, but UTXO is also very popular.
Do you know Do you have an example of one that has an account-based model?
Well, Ethereum has an account-based model. Basically,
okay.
you have a wallet and it's like, well, account-based model, so all the balances are in wallet.
Okay. Okay. I didn't know that. I'd never looked at under the covers of Ethereum, but okay, cool. Anyway, this is the same as Bitcoin, like you said. Cool. So the next thing we want to do is, now we have some money, so we can actually do something. So the first thing we're going to have to do is we're going to have to get these protocol parameters. That's something you can get from the sorry, let me just copy this testnet magic again. So I'll just gem it at the end. So we need these protocol parameters, and one thing I didn't talk about is this Mary error as well. So Mary error is basically just saying, like, yeah, this Cardano CLI has commands that work differently for different errors. So the one we're on right now is Mary. So you kind of, a lot of the commands need this Mary error parameter. So anyway, these protocol parameters, I'll just get them and then so this kind of did a query again, asked for protocol parameters this time, and saved them in a file called protocol.json. So if we look at it, it's got a bunch of things around to do with, you know, some general blockchain parameters that are currently set up on the chain. What's important about it is that you need this file in order to calculate the transaction fee. So this is how you get it.
Gotcha.
Yeah.
And how are you using that to calculate a transaction fee? What part of that?
We'll get there. Okay. There's a command that actually lets you calculate the transaction fee, but in order to run that, you need this file. So you kind of only have to get it once, and then you're okay. So this is how you get it. Cool. Next. So we have some ADA. We have a protocol JSON file. The next thing we're going to do is we're going to create a little directory called policy. So basically, when it says policy, what it really means is a minting policy. So every asset on Cardano has a policy. Even like ADA has a policy, but the policy for ADA is you can't mint it. But yeah, like so they all have it, and you'll see we'll have a policy ID, and that policy ID ends up identifying our token uniquely on the blockchain. So that's what policy is doing, and we're going to do some more key genning. So yeah, we're just generating an address again, an address for the policy, and it's got a new verification key file, which we're just putting in that policy directory, and also a signing key file, which we're also putting in the policy directory. So now we have that policy. And there's a policy script. So this is just making an empty file called policy script. In fact, we can probably just do that for now. So that's just touch is just a command that creates an empty file. And now we want to actually create a hash. So what this does is it takes the policy V key, so the verification key of the policy, and creates a hash for it. Looks like that. So we're going to use that. And
that is the minting policy ID?
that's the hash of the policy.
Okay.
Yeah. So what we're going to do is, so that's a hash of the signing key for the policy that we've generated. A lot of moving parts. And what we're going to do now is write a little JSON file, which we'll call policy.script. Just, can you just give me a second? Sorry, I'll just, I've got some background.
No worries, brother.
Yeah. Okay, sorry about that.
No worries.
Okay. So the two things we need, this is a JSON file, and it's going to need two things. One is a key hash. And the other one is a type. I think it's called, yeah, it's called type. And that key hash is going to be that thing. Oh, sorry, habit. So policy script. That's what it looks like.
Gotcha.
So this,
and that's like your signature.
That's your signature of your key in there. There are some other things you can put in there, especially like when we get to NFTs. We're going to have the ability to put a time limit on this policy. So this is, and a few other parameters. So this kind of, yeah, right now we're just creating native tokens. So they're like open-ended and we can create as many as we like. But only the person who can, has that key hash. In other words, only we can do it. So that's the meaning of this policy right now, but I'll just mention now that it has other parameters like time limiting, how long tokens can be minted for and stuff like that. And that's how we use the same concept for NFTs. Anyway, gotcha. For now, straight tokens. And the next thing we do is we create a policy ID transaction with this command. So yeah, Cardano CLI transaction policy ID takes a script file, which is that script that we just made, and it'll go out to this policy ID file. So these right arrows just mean take the output of this and put it in that file there.
Okay.
If you wanted to, you could run it without to, but anyway. So if you look at that policy ID file, it's just a big number. So that's our.
But if you were to put that in Cardano scan on testnet, that would be the minting policy for this token.
Yes.
Gotcha.
Once we have submitted it.
Yeah, once we've minted something.
Yeah, that's right. So next thing we do is
just to make sure everyone's kind of tracking along to the policy ID is really will be the rules of the token, and the key hash is the person signing off on those rules, correct?
That's it, exactly. Yeah. So the key hash is the person signing off. Whereas the policy ID is like the unique identifier that identifies that token. So
and the rules to that token, correct?
Yeah, and the rules to that token. But specifically, like that ends up being the most unique thing about it. So you can always find it, like it'll have a name and stuff, but that's not the important thing. Like the important thing is this this policy ID.
And the reason that's important that you bring up is because it is possible that things be named the same thing on the blockchain, but their policy IDs is what's going to differentiate.
Yeah, exactly. And like they're all equal in the sense that the names are polluted by that policy ID. So there isn't going to be a market for like well-named tokens or anything like that, because they're all like yeah. So there's no concept of a domain name or anything where you can get nice like that. You can name them whatever you like. They're unique to the policy ID. Yeah. So let's just do that. That UTXO query again, just make sure nothing has changed. Of course, nothing has changed, but that's because we're nearly ready to actually do the minting. So now, first thing I'm going to do is put these things into some variables, which is going to be really useful because then we're going to be able to use the same scripts over and over again. So I'm saying I'm making a variable called transaction hash, which is going to have that. And this transaction index, I'll do that as well. 0. I've never seen it not be 0, but I think probably if you build bigger wallets where lots of transactions, then it's going to go 1, 2, 3, 4, you know, have a few things. So it's an important factor, I guess. And
now, are you submitting each one of these commands after you type it, or are you running these in a batch? How?
Oh, every time I push enter here, it's being submitted.
Executed.
Yeah, that's right. So this is just you could make a batch script to do this, and that might be a good thing to do. We could even, one thing we could potentially do is like wrap this in a script so our users don't have to, you know, type each thing. But I'm specifically exporting each, like I'm executing each step so I can talk about it, basically.
Yeah, that makes sense.
Yeah. So these are just variables that we've set. So, you know, if I echo one of them, yeah, that's the hash there.
Yeah.
So on. And then we're gonna basically build a transaction, a raw transaction. So I'll paste this command in, and then I'll talk about what it all does. So that's the command. So essentially, what are we doing? So we're building a raw transaction. So every time we build a transaction using the Cardano CLI, you start with a raw transaction. A raw transaction basically doesn't have any fee, and it hasn't been signed yet, right? So those are the two things we have to work out. Like, so we build a raw one, we work out the fee for it, then we build the same thing but with a fee, and then we sign it, and then we submit it. That's always the process. So initially, so it's build raw, marry error. It's weird, but you put in a fee of 0 initially. Because you're not going to know what the fee is until you calculate it, but you need a transaction in order to calculate it. You start off with 0. And then the transaction in parameter, we've got this we've got these two variables, and that's going to work. But what I might do, just for kind of educational purposes, is I might actually substitute this so it's so we're not using any variables. So we'll do.
Yeah, makes sense. Just make it a little more clearer.
Yeah. So we're taking the hash and the index, and they're separated by this pound sign.
Okay.
Same with the payment address. We can also output that directly.
It's kind of nice though watching you replace the variable text with the.
Yeah, it's just like, I think it helps. And ultimately, if you want the stuff in a script, then you want the variables. But if you're just doing it, you might fill it in just like that. Okay, so available Lovelace, we had, that was set. So yeah, that I want to show you. So the way this works is you've got a transaction out, it takes an address, and then you give it a plus the available Lovelace, meaning basically that on the out transaction, it's going to come out with 5,000 5 million Lovelace, just like it came in. So transaction in is just, we don't have to tell it anything about what the balances were, because that transaction was already committed. But for this one, you have to tell it what its outputs are. So at the end of this transaction, we're going to have 5 million Lovelace, and we're going to have some of this new token. So let's take the token amount. Any suggestions? How many have you sold? Boone, maybe we can use that as an example.
Well, let's just make a hypothetical one for
Sure.
of 1,000 or 5,000. Yeah.
Cool. Now we need that policy ID. Next. That was there. And finally, a token name. So this name is whatever we want to call it.
Just call it, ADA maker test or something.
Yeah. ADA maker test. Something like that. Yeah. Cool.
Yep.
And so that's the out transaction. And then here we do the same thing as before. So we say 5,000. Policy ID. Yeah, so let's have a look at what everything's doing. I'm just gonna, oh yeah, no, this is all okay. Yeah, so this it's building a transaction initially with a 0 fee, with this as the input, and essentially we've got this output, which is, the output is this address, our current address. We'll have, as the output, it'll have 5 ADA still, and 5,000 of this token. And this token name is policy ID.ADA maker test. So those are the inputs and outputs. And then we specifically say, and what we're doing is minting 5,000 of this policy ID.ADA maker test. and we're saving that whole thing in a raw transaction file. So that's that out file equals matx.raw. And yeah, that's it. That should, we've got some, let's see what our errors are. I suspect I know what it is.
It says unexpected letter or digital white space at the end of out.
Oh, and the transaction out, yeah. So I'm just gonna like,
You know, at the maker test, maybe it's not possible to use like symbols. Well, it
no, it is. That's just whatever name you want.
so.
Oh, I see. Those symbols. Yeah. No. Yeah, good call. And that's what it's actually complaining about, isn't it? Thank you for actually reading the error message.
That's what I meant, because you know,
yeah. All right.
And also,
Good
one
catch,
more,
brother.
is it really possible to set fees 0, or
No. So there are 2 stages, right? First, we build a raw transaction, then we run a script to calculate the fee, like what the fee would be on this particular transaction, and then we recreate it with the correct fee. So it's kind of a weird 2-step process.
Yeah, the system has to look at what you're doing to estimate how much it's going to cost.
Yeah. Like technically, you could do this in 1 step if you had a way of quickly generating. Like if you're writing a program to do this, you'd give it just enough, you know. Yeah.
You could always go to, if you had a good familiarity and had started to, you know, mint enough stuff that you had seen what transactions cross. If you weren't super concerned about saving every Lovelace, you could just set the fee slightly above what you know always works, right?
Yeah, but I don't, in practice, I think you would just always calculate it. There's no reason not to, like, because if you're doing this, you know, you would do this via a script if you actually did it a lot. So the script can just do the the fee calculation every time, basically.
Gotcha. Makes sense.
So we've created this transaction file. By the way, these names are arbitrary. I've chosen the names of files based on the article that I kind of built this lesson on, but it can be, you know, that can be anything. Like, it's just, the main thing is that this is the raw transaction. So
Gotcha.
That's what it looks like. So now we have to calculate the minimum fee, which is and we need that testnet thing.
It's probably might be very different from the mainnet, because like on the testnet, well, basically ADA is free. You can get it like from the
Yeah, but it's actually quite similar for some reason. I don't quite know what factors go into actually calculating it, but you know, when I've done ADA transactions on the mainnet, it's cost me about 0.3 thereabouts, and that seems to be roughly what it costs here too. So I don't know. That's
because I think it will be like a big feature of Cardano that the fees might be paid in native assets, and that's interesting. But
I don't. So my understanding behind that though is the only way that will ever come into effect is if certain stake pool operators decide to accept those native assets, but those stake pool operators still have to pay the transactions in ADA. So at no time will you ever not be able to use ADA in a transaction. You just might have certain SPOs that allow you to do transactions in other
Yeah.
tokens, but the SPO still has to pay in ADA for those transactions.
Yeah, that makes sense. Yeah, because ADA is still kind of fundamental in the sense that, yeah, it's always going to be ADA that's paying for transactions, and it's always going to be ADA that's being rewarded for staking. So you can't stake your native tokens either, not directly. I mean, although again, you might have a native token that a stake pool operator is willing to pay you interest on, but that's a different, or anybody's, that's a different kind of thing.
It
So
really
maybe
comes down to the SPOs to decide what they do with or without native tokens.
Yeah. Cool. So we've got this calculate min fee. So that's another command inside Cardano CLI. It takes the transaction body file, one input, one output. Again, the input is the previous transaction. The output is the new balance on this account with the new tokens plus the existing ADA that goes largely unchanged. Witness count is 1. We'll just trust me on this one. We'll take it. I don't want to go too much into what that means. And then we pass it that protocol.json, which we'd downloaded previously. So that's the fee. So no, you're right. It's much cheaper than mainnet. So mainnet is about 30 cents, whereas this is about, sorry, not cents, 0.3 ADA, whereas this is 0.18 ADA. So it's like a bit cheaper. Cool. So that's an important number to remember. So when I paste in the next, when I paste the next thing in, basically now it's going to be very similar, but slightly different. So if we go back to that build raw, now the fee is going to be that number, but also the out transaction needs to be updated.
It's got to be minus that from the balance.
Yeah, so that part there is going to be different. So I'll just open a new tab and quickly calculate what it should be. I use Python for this, but you can use whatever. So that's the result. So that means we're going to end up with plus this many ADA and plus 5,000 of the new token. And we can rewrite into the same file, right? Because we don't need the old file. It was really only for the calculation of the token, of the fee.
Okay.
So that's a new transaction. Now all we have to do is sign it and submit it. So
the transaction that you just created is the minting transaction, but it has not been signed yet.
Yeah, so it's like, it's a transaction that we've created, but not submitted. So it only exists on my computer here. It's not on the blockchain yet. It hasn't been signed. So
Gotcha.
The next step is going to be signing it and then submitting it. It's only when that submission happens does it actually go on the blockchain. So all of this is prep work for actually doing that minting transaction on the blockchain. Right. So there's another command. So yeah, Cardano CLI transaction sign. And this time we give it a signing key file. And we give it our payment signing key, which is like, that's our, move money around kind of signing key. And we also give it this policy signing key as well. So there are 2 signing keys in this case for this particular token. And we give it that script policy. Then we do the testnet. And we give it a transaction body. And we output it to a signed file. So before it was raw, now it's .signed. And that's everything that should be signed. So if we look at matx.signed, it's got a big signed thing in there. Cool. And now the moment of truth is we submit the file. So again, it's Cardano CLI transaction submit, TX file, which gives us the signed file, and we have to do this testnet magic. And so no news is good news, basically. Like if it does that, that means it worked. If you do something wrong, then it'll give you an error. So if we go back to that, viewing that UTXO now, we have that much Lovelace and 5,000 ADA maker test tokens.
Nice.
So this is done. We have it. Now, the next thing we should do is go through a very similar process again to transfer it to a Daedalus wallet so we can actually see it. So I'll go through the process of doing that now. So let's go to Daedalus. Can you still see my Daedalus, or is that gone? You can see it. Cool. Yep. So we'll just get we'll take an address, a receiving address. And what I might do is, we'll put that into a environment variable just so it's easy for us to use later. And I can also so I'm just also putting that same thing into a file as well. So it's in the file. That's just to make it, easy. So now we want to create a transaction again, basically to move this thing into our recipient address.
I know we haven't quite gotten to the, we're just kind of hitting this, starting this, but it would be possible in command line to create a transaction where, in theory, you could send one of these tokens to 5,000 different addresses, or can you only do a transaction into one address at a time?
No, you could do multiple. So you could have this be the input and have 5,000 transaction outputs, each of them getting one.
Gotcha.
You probably wouldn't want to hand type something like that. You'd end up with a script to generate the command, But essentially, you can do that because you can have essentially as long as the inputs and the outputs kind of add up and the transaction fee is correct, you're good. You can you can have any number of inputs and any number of outputs. So good question.
Okay.
Cool. So what we're going to do is build one of these raw transactions again. It's going to be Mary error. Again, we're starting with a 0 fee because we don't know what it's going to be. And now the transaction in will be this hash this. That's just kind of how these are. So it's always the hash key or pound sign, I guess, and then the index. And the transaction out will be, well, let me just quickly look at my recipient address. Yeah, so that, and they will get 5,000 of, I guess we have to put this in quotes just because it's all one command. Oops, too many. So if you got any spaces in a parameter, you have to kind of enclose it in quotes to make it not break. So it's going to be 5,000 of these. And an out file is going to be again just a new file with a raw transaction in there. That's what it looks like. Again, same thing. We have to calculate the transaction fee. And the body this time is that recipient made X raw. One in transaction. One out transaction, one witness. And where's our testnet?
Does
magic?
witness have to do with like a block count, or what does that mean, witness count?
I think it's basically saying how many keys have to sign this transaction.
Okay, yeah, that makes sense.
Yeah. So that's our testnet magic. What else did we need? Protocol params file. So that's our minimum fee. I think it was the same. So then we can do the same thing as before. Except it's a little bit more complicated now, because basically, how are we going to do this? Let me just think about it for a second.
Well, you can make it simple by just sending all the Lovelace back to that wallet.
Yeah, that's where I was going, because otherwise, I mean, you could do it separately. So there's two ways.
My one question experience with this though is, in sending NFTs or in any other token besides ADA, on the Cardano blockchain, you always have to have one ADA plus the transaction fees, is what I've come to realize. And so do you know that if, for example, if you tried to run this and send these to yourself with just the ADA fee, can we see if that will go through without the one ADA always having to be in a transaction? I'm just interested to see if it fails.
Yeah. Okay. I wasn't aware of that, but I've never done it without ADA alongside.
Yeah, like if in this case, if the the output is that this minting account still has all the ADA except minus the transaction fee. Will it work?
Yeah. Okay. So yeah, we can try that. But I believe we'll have to reconstruct the transaction because there'll be two outputs. One is the ADA going to this account, but one is the change going back to the original account. So yeah, let's do it. Let's it gives us practice. So we'll just do this, but I'm actually going to build a different transaction. So,
and the reason I bring this up is so, for example, when I send an NFT lab access pass to someone, yeah,
you don't want to send
from my
ADA.
Daedalus. Yeah, it always makes me put one ADA in the transaction, at least one ADA, and then it also has my transaction fee. So I'm always sending.
You're
ADA
spending
plus
like 1.3 ADA instead of 0.3. Yeah, makes sense. Okay, so let's try and do this. So we've got this transaction output, which takes let's see.
And sorry to interrupt you. Maybe can we actually break this up into two transactions? So we do one transaction where we send half the new tokens, trying to just send the new tokens plus the transaction fee, and then maybe try a transaction where we send the other half of the tokens with all the rest of the ADA.
Yeah. Yeah, that's cool. We can do that. Either way, we will have to. So let's go back to the raw transaction. And we'll set the fee to 0 again. And the transaction in is going to be this. #0. And I'm just going to start the next line. Then the transaction out is going to be let's see, we just have to make sure that all of our money adds up. So previously we had the transaction out, where was it? I'm going to this address. So yeah, I'll just copy it first of all, like that. But now we're also going to, on top of adding those, we're also going to say plus let's just send 1 ADA with this one. Just as doesn't have to be exactly. Oh, we wanted to do 2,500, right?
Yeah. Don't send all so we can test. That way we can do a little experiment.
Yeah, and then plus 1 million. Is that a million? Yep. So that should send 1 ADA and 2,500 of our token. And now that's the key thing. What we're going to have to also do is build up a change transaction, which is, remember that when we use this as an input, this whole thing gets spent. So there's no wallet, right? We have to spend this whole thing. So that means if we want to return something to ourselves, like if we want to be left over with something, we have to create a change transaction as well. So
yeah, so the rest just goes to stake pool operators. Yes.
No, it's not going to work, I think.
No, yeah,
the stake pool operators get the fee, but yeah,
Yeah,
The rest
the
is-
balance always has to end up in either the input or output.
Yeah.
For example, like in Bitcoin, it would go like to miners, as I understand.
The fee would
fee,
go.
but you're still not allowed to get the accounting wrong. Yeah. If that makes sense.
Yeah, so that the node operators are always going to get the transaction fees, but they
Yeah.
don't have anything to do with the balances of the accounts.
Yeah. I
Yeah.
mean, if you don't put like the transaction of the rest, so will it go like to?
It will reject the transaction.
Yeah. Thanks. That's what I was.
Yeah. Cool. So we'll go. So this one here now should have. We've got to do a little bit of math here. So that minus. How much did I give this one? 1 ADA. I used to be able to do these kind of things in my head, but
That's a lot of numbers to do in your head.
yeah, it's kind of long, and then there'll be 2,500 exactly of this thing too.
I think that the what you're missing though in that balance is the transaction fee.
Yeah,
still
yeah.
need
I am just constructing this thing, and then we'll update it with the transaction fee once,
Gotcha.
just like we did it before. Okay, and then transaction out. What was that? And we'll write that to the same out file as before. You can see this is kind of quite fiddly to do, but I guess for the minting part of it, you still got to do it like that. So it's like quite a. You have to be super careful when kind of doing those things, but yeah. And now we'll calculate the minimum fee. This time the input transaction count is 1, but the output transaction count is 2.
Yep. Okay.
Sorry. Just 1 second. I'm just yeah, there we go. So transaction out count is 2. Witness count is still 1, I guess. Yeah. Testnet magic is here. And then protocol params. So, all right, that ended up being very similar to before. Cool, so that's our fee. So now we have to take that fee and take it away from one of the recipients. I'll take it out of the change rather than the recipient. So that's that was the change was here. So it's minus that. So that's going to end up being the change. So that is going to go here. And we'll, yeah, so we've updated the fee, have we? No, we haven't. So we've got to go up to the fee and set that to that. So in theory, we've didn't complain, but it usually will complain later if we did it wrong. So now we have to sign it like before. Just, yeah. So signing key file. Testnet magic. And out file. Cool. So that should sign it. Yep. And now the moment of truth.
You're missing the equal sign under after testnet magic.
It actually doesn't matter.
Oh.
Output too small. Okay. So this is where it, yeah, we've done the accounting wrong, basically. So I'll just, now we have to, so our transaction that we made was this.
Try, take the, and even, let me think, take that 600,000 and add it to, so that the person getting the 2,500 now is going to get 1,600,000. Because I think from my experience in sending NFTs, I feel like that they're not, this was the kind of the problem I was trying to experiment with you on, is to figure out what is the minimum ADA a receiver of native assets has to get in a transaction. And right now,
yeah, that's a good question, but the way I read the error message is the problem is that our numbers don't add up. Right. So what I want to do before we do that is just go back to the drawing board and just kind of add up all of our numbers that we had and see what they see, make sure that they so I'll just go back and so that's what we should have, that much Lovelace and that much token. So I'm just gonna basically, I'll just go to the end of our, so what we have is, I'll just write it here and then we'll get rid of it. So tokens 2,500 plus 2,500. I think we're good here. That's 5,000. Yeah, so I think the tokens are okay. Now the ADA. Let's see. Fee is supposed to be that much. And then we output that much into one and that much into the other. And I'll just take this whole thing and paste it somewhere where it'll calculate it for me.
every time you go to your Python tab, we can't see it, but I know you're only adding.
Oh, can you only see the one? Okay.
Yeah, but that's fine. I mean, you're only doing the adding, subtracting.
I'm just adding stuff. Yeah. So the sum was this. I'll just paste it here.
That's correct.
That's correct.
Yeah. So I've tried this experiment.
Yeah.
Give an extra 600,000 to that other one and take it from the other one and see if it goes through, because
Yeah.
I've noticed that I have to include 1.6 ADA.
Strange.
Just
yeah. Okay.
Yeah, it's very strange.
Yeah. So 600,000
should be a 0 now.
Maybe this can be because like sending like tokens or sending NFTs is really more expensive than sending just ADA. I've seen it also in some other blockchains than when you send the token.
But this is not the transaction fee, right? This is like you have to send some money along with it.
Yeah, this is a requirement of it's not the transaction fee, it's a requirement of the minimum amount of ADA just being in a transaction.
Yeah, I also noticed that on some wallets with ADA, you can't like send transactions if you don't have like this around this same amount of minimum on your balance.
Yeah, so that worked. That just worked. I just submitted it. I signed it like before and I submitted it.
Yeah.
Okay.
So there is right now in Cardano a minimum of 1.6 ADA to be included with any other token that you're sending, whether that's one native asset or in this case 2,500 of those native assets. You're required to have 1.6 ADA plus your transaction fee. Yeah,
which is at the moment it's fine, but you know, if ADA goes up, that can become quite a burden.
Yes. Yeah. So hopefully they're, you know, I mentioned this to someone at IOG, and they had said that they are, you know, it is something they're looking into. So be interesting to see how that kind of progresses, because, you know, like you mentioned, it's not too bad right now, but still, if ADA goes to $10 or something, and you have to include $10 worth of ADA just to send a NFT, it starts to become very expensive.
There will be consensus to lower the transaction fees, and there is possibility to submit a SIP, Cardano improvement proposal. So we'll need to check if there are already some such incentives, and if there are no, then we can submit a SIP from other makerspace.
Great idea.
Yeah, I mean, it's not the transaction fee so much. It's just like, it's just because this doesn't go to the stake pools, right? This goes to the recipient.
Yeah.
So,
but I agree with Andrew that we should submit a SIP that you shouldn't have to have a minimum of 1.6 ADA, you know, so going to the recipient as well, right? Because you really the only ADA that should have to be included in your transaction would be, in my opinion, would be the transaction fee.
Yes, I agree. You should be able to send tokens alone. Anyway, so I've looked at my UTXO now, and you can see I've, you know, spent a bit of ADA, and I've only got 2,500 of these.
How about your Daedalus? Do you have that new token in
That's the
your
next step? Yeah. So if we look at transactions,
there it is.
Multiple tokens received, right? So we received 1.6 ADA and 2,500 of this token, which is from ADA Maker Test, and it has the policy ID.
Very cool.
So yeah, we have it. We've done native tokens. Now,
can we just do one more test real quick with copy and pasting that transaction in one time? And just to confirm it fails again, just try doing the transaction where the person that has the 3 ADA right now would still have all their ADA, and the other person receives no ADA, just the token. I'm sure it's going to fail, but I'm just interested to see it.
Yep. So we'll start off with this, and then we'll I'm going to take a gamble that the actual transaction fee is going to be the same, but if it's not, then I guess we'll fix it. So this time the input transaction is this one, #1. This one. This time we've got an index of 1. So
yeah.
Okay. So the output is
0 ADA.
Yeah, 0 ADA.
And the other, and the rest of that 2,500.
2,500 of the of that, and then the change is going to be all of the ADA
minus transaction
fee. Okay, I'll put that in here for now, and then I'll take care of the fee in a second, and no tokens because they're all going to the recipient. Yeah,
correct. Yep, correct.
So like that. Cool.
Yep.
And now we just have to do the transaction fee, which is I'll just do the calculation quickly in the other tab. So that's what's remaining, 2.8. So we'll try that, yeah?
Yep.
So we sign it first. You see, I'm kind of overwriting those previous files, and I think that's fine. Once it's on the blockchain, you don't need the intermediate files anymore. So you can just keep rewriting them to the same thing. Okay, and let's submit and see what happens. No, output too small.
Yeah. Yeah.
So,
okay.
Yeah.
But in my opinion, that should be a way you should. I mean, the way you should be able to send native assets, as long as you're paying the transaction fee in ADA. In my opinion, you shouldn't have to also send a person ADA that you're just trying to send them an NFT.
Yeah, I completely agree. It's a strange example. Like it's like why 1.6? What's
and my other thing would be, if the infrastructure requires that you always have that receiver also receiving ADA, then it should be much less than 1.6 ADA,
Yeah, it should be something like comparable to a transaction fee.
Yeah, I agree.
Yeah, I completely agree, and I don't really understand the reason why it's needed. I guess it would be good to raise that question and see what they say.
Very cool.
Yeah, and it's a little bit of when I read output too small UTX, I think that kind of means that the accounting wasn't right, but you had the right hunch. It was because that ADA wasn't sent. So yeah.
And the only reason I know that is because I've been sending NFTs from my Daedalus, and every time I go to send one of them, I always have to include 1.6 ADA in my transaction.
Yeah.
So well, we've covered a lot. So I mean, if we want to reconvene another time, and if you would do us the favor of just shooting the shorter version of how you would do the same connection to Daedalus with Windows.
Yeah. So I will basically, I may record it or I may write the article. We'll see how my recording on Windows goes, because I don't normally do that. But yeah, I'll spin this up on Windows. Give me a few days to produce the Windows version, but it'll be a few days. It won't be too long because the concepts are the same. It's just some of the shell stuff is, but it should be directly comparable to this one in terms of what we do. Maybe with some little bit less trial and error, I guess, because we've done the whole lesson now, so we know the steps. So yeah, I think the next step is I'll do the Windows one, and then next time we'll do the NFT version, which is actually, now we've done the hard work. Like, it's what's different about an NFT versus this. Two things. One is the policy has an expiry time, like an expiry slot. So when it hits that expiry slot, then all of your, those tokens can no longer be minted or burned. So right now we have the ability to burn tokens. We can mint some more. It's completely up to us. With an NFT, it's done using an expiry slot. So you say, I'm going to mint this NFT in the next, if you're brave, you can say 1 minute, but because you're doing it manually, give yourself half an hour. Mint it during that time. If you're happy with it, let the time expire, and then you send it to someone. So that's one difference. Basically, because what makes them non-fungible is the fact that you can't get other ones, and you only have one. So yeah, that's the primary difference. And when you have that time limit, once it's expired, you essentially have an NFT. The other part is the association between like an image or a piece of art or whatever that people are doing with NFTs these days. And that's going to end up being writing some metadata to the transaction, to the minting transaction specifically. So yeah, that's going to be kind of the next step, like altering that minting transaction to, yeah. So yeah, that's the difference between NFTs: time limit and metadata pointing to the actual piece of art. So that's kind of what we'll cover next time, and it should be much cleaner than before.
You must have like a document where you have all these that you're copy and pasting off of.
Yes. I'll send you, because we should credit the article that I mostly worked off as well. So it was one of the articles in the resources that you sent me. So I'll send you my documents
cheat sheet
and my cheat sheet and the article that I'm mainly based this on.
Appreciate it.
Yeah. Cool
beans, man.
Cool. All right. Well, I hope that was informative, and I'll send you the Windows version, and hopefully let's continue next week.